Okay, so this example right here, very similar to what we did yesterday. And what we're going to look at is a table instead of a function. We're not going to plug it into your calculator. Is that okay by you? So the AP exam is it's very common for them to give a table instead of that function. And what it asks you to do is consider the concavity of this function and determine an upper and lower bound for the total amount of snow accumulation over the course of 6 hours. So let's look at this right now, and it says that you have a certain time and you have R. This is the rate at which snow is falling. The rate at which snow is falling. Okay? So at time 0, there's no snow falling. And at time 3, there's 0.6 inches of snow falling per hour. So that means over the course of an hour, you should end up with about 0.6 inches, right? Whereas at 6 hours, it's coming down really hard, isn't it? Like we are in a big time blizzard. So I want you to think about this graph right here as we consider this. What do you notice is happening to the values? Yeah, they're getting considerably larger, aren't they? In fact, if I were to just kind of model it, 1, 2, 3, 4, 5, and 6, and 1, 2, 3, 4, 5, we have 0, 0. And sometimes people ask, well, how do you know if you're supposed to graph it? You don't have to, but I think this is going to help you get a visual for the first time. We got 0.1 that's really small. 0.3 is really small. 0.6 is really small. 1.2, 2.4, and 4.8. So that diagram's approximately the rate, okay? I want you to have a conversation with a friend next to you and decide, suppose we were to do a right-hand sum, and suppose we were to do a left-hand sum. Would the right hand be an overestimation or an underestimation? And would the left hand be an overestimation or an underestimation? Talk with your peer next to you, see if you can figure it out. Go. And stop. Is the right hand going to be an under or an overestimation? Over. As you look at this piece right here, notice at 6, if I go up to the top, that is an overestimation. So, let us do upper bound. We're going to do a sum. True or false? The width is the same every time. Yes, the width is what? 1 times, and then we do the sum of the heights. Where will I evaluate my first height? Yeah, so I've got 0.1 plus 0.3 plus 0.6 plus 1.2 plus 2.4 plus 4.8.
So pretty much part A, we're just finding the right and left hand side.
Yep. So I have 1.1 plus 0.3 plus 0.6, that's 1. Then I get 2.2. Then I get 4.6, 9.4. So 9.4 inches have fallen approximately. Then the lower bound, that would be a right-hand sum or a left-hand sum. A left hand. If you're going to do the left hand, that means that you would be going up to, yeah, we would stop at 2.4, wouldn't we? So we'd start by adding on 0, and then we would not add on the 4.8, right? And so if you take off that 4.8, 4.6. We all good with that? Good. So it would be reasonable to say that at least 4.6 inches have fallen, but no more than 9.4 inches have fallen, right? So, you know, you might try to go for the middle there. Let's look at letter B. It says S of 0 is equal to 2.4. 20-second conversation with the peer next to you. See if you can figure out what the heck that means. Talk. Go. Awesome. 5, 4, 3, 2, 1. At time equals 0, there is what? There is 2.4 inches of snow on the ground. That's what that means. At time equals 0, time equals 0, there is 2.4 inches of snow on the ground. That's what it means. There's a starting, there's a base amount. So now we kind of want to know, well, how much snow is there? Like, can I let the dog go outside? Well, if it's a St. Bernard, probably. But if it's a Jack Russell Terrier, then probably not, right? At time equals 0, S is 2.4. So S is the position, it's the amount. But at time equals 0. Okay? So, yep, S of T. Yep. So use T sub 4. What does T sub 4 mean? What does T mean? Trapezoidal sum. Use the trapezoidal sum at 4 rectangles. Do you remember how we compute trapezoidal? Right and left, add them together, divide by 2. So let's find R sub 4 and T and L sub 4, and let's divide by 2. And that will give us that trapezoidal sum. Okay? We found R sub 6. Yeah. So let's do R sub 4. Where are we going to start? 0.1. We add 0.3 and 0.6 to get 1 plus 1.2, 2.2. So it looks like the right of 4 is 2.2. And then for the left, we are going to start by evaluating at 0 and go up to 0.6. And what do you get if you add that together? Just get 1. You divide by 2. So you get 3.2 over 2, which is 1.6 inches. Is that my answer? Because that's what I do on the test sometimes, and I get it wrong, because that's not correct. The question is, approximate the amount of snow coverage at that time. We have to add on the 2.4, don't we? Yeah. Yeah. So remember what this is building off of yesterday, which we said is start plus displacement. Remember? So we take our start, which is 2.4, and then we have a displacement of 1.6 more. So 1.6 plus the 2.4 is how much? 4 inches. There's 4 inches on the ground right now at that point, approximately.
Oh, yeah, because at S0, there's 2.4 inches. So pretty much, so what we just did the trapezoidal sum.
Yep. Yep. Good. All right. 2 more parts. This part's pretty simple, but it is a little bit different. Approximate R prime of 3. We want to find this derivative. Do we have an equation up here we could type in our calculator to find a derivative? No. So when it says approximate, what that means is we are going to find the slope. Okay? Nice. I want to find R prime of 3. So that's going to be the slope at 3. If I want to find that rate of change, here's one thing that I can do. I can use the spot in front of it and the spot behind it to find the slope. So if you want to approximate R prime of 3, what we're going to do is we're going to take R of 4 minus R of 2 divided by what? Good, yep, 4 minus 2. So r prime of 3 is approximately that. We don't have a formula that we can use, so we got to use a point behind it and a point in front of it. And if you just look at this drawing here, you can tell that if you connected the lines from 2 to 4, that would be about the same slope as what we're looking at there. So what is r of 4? 1.2 minus 0.3 over 2. And I get 0.9 over 2, which is 0.45. Anybody know what my label will be? Inches per hour squared. So the reason why it's going to be inches per hour squared is rate is inches per hour, but we've taken a rate of the rate. Okay, so that's your second piece there. Okay, suppose I want to do 4.5. Do we have a spot up here for 4.5? So what two values should you use? 4 and 5. So r prime of 4.5 is approximately r of 5 minus r of 4 over what? 5 minus 4. What is r of 5? 0.1 minus, oh, sorry, I heard 2.1. We got 2.4. It's 1.2 over 1, or 1.2 inches per hour squared. So that's how fast the rate is changing. So the snow, the rate, it's accelerating. You're bringing more snow on in. Yep. Okay. Quick, have a 30-second conversation with your peer. See if you can reference what you think that was from yesterday. Can you remember what that was? Go, talk. What is that thing? Okay, so here's where I get some problems wrong as well. And so I want you guys to try to avoid this. You'll make the same mistake I do. This is what? Do you remember this from yesterday? This is the average. So it's the average rate, okay, because we're given a rate function, the average rate at which snow is falling. It's the average rate which snow is falling. Sometimes I leave it there and I get a point off when I'm looking at my free response questions in the AP exam. I've got to list something else. From what time? Time equals 1 to time equals 5. So you've got to talk about the time frame. So you have to reference the bounds. So from time 1 to time 5, that's what's happening. Okay, it's the average rate. Now, we're going to use a right-hand sum to actually approximate that. I quick want you to just talk with the person next to you. What would you guess is the average value of the rate from 1 to 5? What would you say is the average rate from 1 to 5? So the average of those numbers, what would you say? Go, talk. Don't try to calculate, just take a guess. Just take a guess. 5, 4, 3, 2, 1. Jack, what'd you guess? Jack guessed 0.9. I like that. Anybody else? 0.87. Okay, people have different thoughts. What if I guess 3.3? No. What if I guessed 0.1? No, it's got to be within those bounds. So let's use the right-hand sum to approximate it. So we're going to say 1 over 4 integrated from 1 to 5 of r of t dt is approximately. Oh, and there we are. So we'll finish that off tomorrow. What are you wearing tomorrow? White. Let's go.